This page we are doing example 2 from still linear inequalities, and this says match the graph to the inequality. So up here I have 5 graphs, 1, 2, 3, 4, 5, and down here I have 8 equations. So you're trying to match these to the equations. So since there's 8 of these and only 5 of these, 3 of them won't be matched with anything, so we can eliminate some. Now what you're going to do here is, I'm going to zoom out for a minute. What we want to do here is we want to look and see there's a lot of hints that you can do. So solid lines will have to have an equal to it. So these guys are solid, these are dashed. So dash, 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 these guys are solid. So these solid lines could only possibly be A, B, E, or G. How come? Because solid lines have the equal to. So you can even do a little bit of a process of elimination. So those ones here with the equal to are the only ones that could possibly be these two. So now one of them is a negative slope, right? So if you remember, this is a negative slope. It's heading down to the right. Sorry. And this one is a positive slope, so it's heading up. So that means that we can look and say, okay, I have 2 positive slopes, right? And how do I know that? So what you're imagining is that this is actually y equals x plus 3, and this is y equals x plus 3, right? So that could be equals. But then, when you do that, then you go, okay, is it greater than or less than? Right, so then if you look over here, x plus 3 and x plus 3, so that could be this equation here. Because it's the only positive one, that's a negative slope. It's heading down, so it's got to be this one or this one. So is it greater than and equal or less than or equal? So see how the mouth is open towards the y, so it's greater than or less than. Greater than would be any y points above it. So if you were to test a point, so say 0, 4, you would be able to check that. If you're not sure, you can test a point, but it is going to be greater than, so it's going to be above. So this one should be A. So this one should be A. Greater than, right, the mouth is open, so it's above the line. So this is the line, solid, and it's above. So that's the way you can read it, that the y values would be greater than, so above it. So that one's gone. So this one, we used it, and this one, it can't be used because it's the only other solid line. So then let's try it again. So this is the same, y equals negative x plus 5, so that's my only one with the slope of 0, y-intercept of 5, right? So this means the b is 5, and the slope is negative 1. So that's got to be this one because it's the only other solid line, equal to. Equal to means solid. So it's this one. Now, so when you look at this line, can you see that the shading is below the line? So if the line is here, you're going below. So that's what you're looking at here. Y is below that. So this is greater than, so mouth open towards the y is greater than, mouth closed is below, so this one here is the one I would choose for G. So without even having to calculate, you can eliminate it using like that. So G would be here, and this one has to be gone because it can't be used. Okay, the other 3 are going to be maybe a little bit harder. So this is less than and greater, less than and greater. Oh, and again, look. So when you look at this equation, this is, pretend that this is y equals x plus 3, which is the same as this. So that means that the slope, m is 1. If m is 1, then that means it's a positive slope. So it has to be one of these two. Okay, so it has to be one of those two. Now when you look at this line, this one has a y-intercept at 3. Oh, they both have a y-intercept of 3. Okay, so they're both the same. We're just looking to see if it's below or above. So when we look here, this one's up and this one's down. So this is above, y is open, so above. So D would be above. So when you look here, this looks above, right? So it's above. And then this one here would then be C, which would be below. So it's below the line. So that takes care of this one and this one. And then for my last one, if you're like, okay, shoot, I'm not seeing above and below, I can test a value. So this one here again, picture, if you can, that this is y equals negative x plus 5. So that the slope is negative and the y-intercept is 5, so we know it's this one or this one. And this is less than and this is greater than. So greater than is usually above, less than is below. So greater than would be above and less than would be below. So then I'm thinking h. So h. This would be h. Okay. Now if you look at that and go, and that's it. If you look at that and go, okay, I'm not seeing the greater than and less than. So the other strategy is that you can check a point. So check a point. That's my other strategy. So here, let's go to the h equation. So this one here. I know that the equation is this. If I check a value here, then I go, what do I mean by check a value? Check a value on the y-axis. Or any value, actually, anywhere on the grid, but I like y-axis lines. So if I check a value here and say this point here, that would be 0, 7. So check a point 0, 7. If I put that into this equation, I go, this is my x, and this is my y. So this goes in for my x. Just sub it in. This is just an equation, so sub it in. You're going to get 7 is greater than negative 0 plus 5. Negative 0 is gone, so 7 is greater than 5. Is that true or not true? Is 7 greater, the mouth is open, than 5? That is true, right? So that means that this point is in the shaded region, so therefore in the shaded region. So go up here, 0, 7 should be in the shaded region for h, and yes it is. So 0, 7 is in the shaded region, so that means that is true. So the inequality can work like a true or false statement. Okay? These ones are a little weird when we're trying to look at it and what you're looking at is above and below or testing a value. Okay, it always feels a little weird with the inequalities at first.